SSDs, M.2 SSDs, hard drives. There's all types of storage drives that we can use to store our information and our data on our computer, but how much faster are each of those types faster or slower than the others, and how does that translate into real world performance, and what will you notice it on? Now, let's find out. Although I did a video on this topic a few months back, I was only speaking theoretically at that point, and I am now in a position where I can actually review these drives because my current system has all three types of drives that I mentioned installed, and I can actually run number comparisons and give you uh, exactly how much impact and what the difference is between those drives in terms of speed and how it will affect your performance and where you will notice it the most. Now, there are several ways to measure this. I will use both Samsung Magician, which is a Samsung tool, which is what both of my SSD drives are from, both the M.2 and the other one. And it can test the speed of a drive, and it will give you the numbers of read, write, and all that sort of stuff, so you can compare the theoretical speed of the drive. After that, I will give you some boot time load timers. So basically, how much time it takes for a PC to boot from that drive to Windows. As well as I will give you a short example of I will copy paste big file from one drive to another to see how much of a difference it makes between types of drives when you are copying big files, for example. So those are the three things that I will be doing today, and that you guys will be able to see the numbers and the difference. Now, a quick recap on the types of drives that I'm going to mention. For starters, the good old SATA drive. The hard drives that we are used to seeing in since basically forever on our PCs are these types of drives. They consist of a mechanical spinning magnetic disk, and they can connect via the SATA ports to your motherboard, which can achieve a theoretical speed of up to 6 gigabit per second with SATA 3 type of connection. Now, the SSDs that have started showing up more commonly a few years back, they are more akin to what a USB drive would be. They're similar to hard drives in that they keep their memory, their storage data when they are powered off, unlike RAM, and they are a lot faster, although they still connect to the same SATA port that can achieve the same theoretical 6 gigabit per second. Another reason that they are faster is that that 6 gigabit per second is a theoretical max, while the hard drives, although could in theory achieve that max, they fall a lot shorter than that because of it being a mechanical process. The case with SSDs is it is not a mechanical process like the hard drives. There's no spinning disk, there's no mechanical parts that need to move. It's all digital, so it is a lot faster in comparison, and it gets a lot closer to that max, even if it might not reach it completely. Now, the M.2 drives are the most recent advance in storage technology. They connect not through a SATA port, but directly to your motherboard, either through an M.2 port or through an adapter that connects to a PCIe slot. It can reach speeds up to 32 gigabits per second if it's a PCIe 3.0 slot, which, from what you can already see here, is already kind of a massive theoretical improvement over the previous generations of storage drives. But because theory is just that, let's get some good hard numbers. This is Samsung Magician. It works with Samsung drives in terms of managing their settings and firmware, but it lets us do performance tests on drives regardless of manufacturer and also on older HDDs. Now, what you are looking for here is performance benchmark. This will start a test on your drive, test its speed, read, write, both sequential and random, to give you some idea of what speed your drive is achieving. Now, you should not have other stuff running while you're doing this. I shouldn't even be recording while doing this because it will affect the speed that is reported and the speed that the drive can achieve. So I will just press start and I will pause the video and I'll give you guys only the results because who wants to see a long ass bar moving until it's full? As you can see, the test is completed. You have the results down here along with the date that you took the test. And it is also saved here under all drives along with the date of the test. For the sake of completion and to provide a fair comparison, I will also test the other drives by going back to the main screen, selecting the other drives and repeating the same procedure. The results are in, and I have to give a little bit of a disclaimer because the 970 EVO, which is my M.2 SSD, is being used as a boot drive. The results are a bit skewed because it is being used in the background by all the Windows programs and everything that your operating system is doing, so it does not provide an accurate reading. And it should be a lot higher than the 850 EVO in place of being about half the sequential read and write. In fairness, the speed that it should be reporting, it should be operating on, should be about 5 times higher, 4 to 5 times higher than the Samsung SSD 850 EVO, which is a normal SATA SSD. In any case, you can see the difference a bit better because the random read-write is still quite noticeably higher than the normal SATA SSD, even if not as much as 4 or 5 times higher, but it is still noticeable even despite the fact of it being used as a boot drive. However, if you compare either of those two to the HDD, then the difference, I don't think I have to comment, I think it speaks for itself. Um, it is quite a massive difference. Now, let's move on to some other tests. This test I cannot really show you because I don't have a video capture card or anything of the sort to capture the boot process of my PC. But what I can tell you is that an HDD, depending on how much bloat you have of programs loading at start, like let's say Steam, Skype, you name it, whatever programs you have starting when your computer starts, depending on how much of that stuff you have, you can normally expect an HDD to boot around, let's say, the 30-second mark from, basically cold booting your system to being usable, while with an SSD, you can expect it to happen around the 10-ish second mark. From an SSD to an M.2, you actually won't notice a whole lot of an improvement, but then again, it's already so fast that it would have to be very, very massively faster to be a lot more, a lot noticeably faster than the SSD, the SATA SSD, that is. It is also a bit murkier with Windows 10, which features a rapid boot mode that makes HDD boots a bit more bearable, but it's still very noticeable that with a fast drive like an SSD, be it an M.2 or a SATA one, it is a lot faster to boot and to actually have a usable computer when you start it. Something also worth recording is, for example, the load time in games. So I'll be testing World of Warcraft, which is a game I normally play sometimes, and now I'll be testing how long it takes to load from each drive, from the character loading screen from the second I press enter until I actually get to town. I will skip all the loading because it might get a bit boring. Now the results for this test are also in, and the HGT took a whopping 1 minute and 6 seconds to load from the character selection into the actual game world, and until it was actually playable. The SSD cut that time in about half with a 30-second mark, and the M2 cut it even a little bit shorter at 18 seconds from character select until game world. So as you can see, it does have quite an impact in gaming when you are trying to load a game and load resources for that game and have it playable after that game boot. For my last test, and I will not bore you with the actual testing procedure, I will copy a 5 GB file between drive to each drive, trying to mix and match from one to the other and the other to the other and so on to fully cover the possibilities. And I will try to time how long it takes to copy a file that size from one drive to the other to give you an idea of how that affects workflow and how long you can expect to transfer a file of that size. Before I even show the table of results, just a little anecdotal evidence from myself. I have rendered the same video on Adobe Premiere from my M.2 drive and from my HDD, and the same file that would take about 4 minutes to render on my M.2 drive, it was taking upwards of 12 minutes to render on my HDD. So that gives you a good measure there already of what you can expect in terms of performance in real life applications between two of those drives. Without further ado, here are the results from transferring that file. So the results are in, and forgive me for reading from a piece of paper where I wrote down the results, so I won't be looking at the camera. Transferring from the HDD to the M2 or from the M2 to the HDD took the same amount of 28 seconds. So that is quite a long time for a 5 gigabyte file, and the speed was the same transferring back and forth because obviously when you're transferring between two drives, you're always limited to the lowest of the drives, in this case the HDD. So the speed was roughly the same. Meanwhile, transferring from the HDD to the SSD and backwards as well from the SSD to the HDD took in one case 27 seconds and on the other case 29 seconds. So it is similarly being limited by the low speed of the hard drive in comparison to the other. Now, another comparison that I did was moving the file from the M2 to the SSD and from the SSD to the M2. In both cases, the file took 8 seconds to transfer, and that just shows that it is a lot faster. In this case, it's more than between 3 and 4 times faster file transfer between those drives than between those drives and an HDD. Because as soon as the HDD in the mix, the speed is going to plummet because it just has a much slower read and write speeds than those drives do, and you can clearly see here and how it could affect your performance and how much of a performance boost it would give you to have an SSD or an M.2 drive in your system as opposed to just an as opposed to just an HDD drive. Why is that? And should you still use HDDs in your system at all? Well, yes, for a reason which is mostly pricing. SSDs and M.2 drives specifically are still kind of expensive. SSDs are a bit more affordable. M.2 drives are starting to come down a bit in price. However, for you to buy, for example, 2 terabyte SSD, that's going to be very pricey, and I mean in the several hundreds of euros/dollars price range. So my advice to you is have your operating system on an SSD or an M2 and have your games that you play more often, or your programs that you use more often, or large video files that you have to work on, as in actually edit and such, have them on your SSD or your M2 drive. Other things that you don't use often, like videos, movies, music, whatever, that you don't use as often, have them on an HDD, and you won't have much issues because it can read them just fine enough for you to enjoy a movie or something like that, and you won't be having to spend a lot of money because HDDs are actually relatively cheap, even for larger capacities. My other piece of advice is if you are wondering, should I upgrade specifically from an SSD to an M2 on purpose to enjoy the super fast lightning speeds? It's one of those things. It's nice to have, but I would not say it's a must. You do notice a difference. I'm not gonna lie to you. It is faster. I do feel on my own system that it is faster than the SSD, but it is not such a difference that I would, on purpose, go and upgrade my motherboard so that it will have an M.2 slot. If it happens to have an M.2 slot when you upgrade your motherboard, great, but I wouldn't make it the selling point. I wouldn't make that my point of decision. This is why I'm going to spend more on a motherboard so I can have an M.2 drive. So that is my opinion. What I do think is crucial, and I've mentioned it before in the other video, is if you only have an HDD, please do get an SSD. Even if it's a small one, only for your operating system, you're going to notice it massively, more than almost, okay, more than almost any other computer upgrade you could possibly do. So that is my advice to you guys, and I hope that this testing, even though it is a bit crude, was useful and has helped delve a bit further into this issue of drive types and storage types. This is Ethic PC Guy. Hope it was useful and have fun, and I'll see you next time.